Okay, so if you have this question and you want to solve for the value of x or the values of x, you can use the Lambert function to solve it. All right, so we're going to apply the Lambert function to solve this question. If you don't really know much about the Lambert function, you can check out videos on my YouTube channel for more clarification. All right, so what we are going to do first is to replace the 8 power x with a variable. All right, now we are replacing the whole of this 8 power x with a variable, so we have to get another expression for x over here. So this is how we can obtain that expression. We are just going to find the natural log on both sides. All right, now per the properties or the rules of logarithms, this x over here moves to this side, so we get x ln of a equals ln of a. So we are making x the subject. That means we're going to divide both sides by this whole thing. So we get x to be equal to ln of a over ln of 8. All right, so we proceed to make our substitutions. All right, so we are replacing this whole 8 power x with a, so we get a equals 8 multiplying x, but now x is the whole of this, right? So replacing x with that. Okay, now we can see that this ln of 8 over here can multiply this over here, so we get a ln of 8 equals 8 ln of a. All right, now what at this point you're going to do is to send all the variables to one side and all the constants or the numbers to another side. Okay, so we are just going to divide both sides of the equation. We want to send the a to this side, so we are going to divide this side by a, side 2 by a, but we also want to move this 8 to this side, so we're gonna attach the a to it. So in short, dividing both sides by 8a. So this a cancels out this a over here, so we get 1 over 8 ln of 8 equals 1 over a ln of a. All right, now from here we are just applying the Lambert function. So per the Lambert function, if you have anything of this form, x e power x equals, let's say, a, and you apply the Lambert function, then we have x to be equal to the product log of a. All right, so we just have to make sure that the variable side becomes something like this, then we can apply the product log function or the Lambert function. All right, so since this is an equation, we can rewrite this one first. It doesn't change anything, so we get this. All right, now from here we are at this point. All right, so from here we can write 1 over a as a power negative 1, then multiply ln of a equals 1 over 8 ln of 8. All right, now if you've seen Lambert function videos on my YouTube channel, you know that from here we can rewrite the a power minus 1 as e power negative ln of a, then multiplying the ln of a we already have, then equals 1 over 8 ln of 8. All right, there's a reason why we can rewrite this as this, because this is the same thing as this. All right, it doesn't change anything, they're the same. All right, so from here what we are going to do is, if you remember our condition that we should get it in the form x e power x equals a, that means if you are to apply that same principle over here, we have ln of a, but the power over here is minus ln of a. All right, so we have to find a way to make sure that this side this side here becomes ln of a, negative ln of a. They also have a negative ln of a over here. So what we are going to do at this point is to multiply both sides of the equation by negative 1. Alright, so if you multiply both sides of the equation by negative 1, we get this. If we multiply both sides, I'm sorry. Okay. Right, so if you multiply both sides by negative 1, we get this. Equals negative 1 over 8 ln of 8. Alright, now you can see that this is the same thing as this. Right. So we can apply the product log on both sides. Right. So it is represented with a W, capital W. So we get something like this. Equals W of negative 1 on 8 ln of 8. Right. Now, per the principles of the product log function, this whole thing can be written as minus ln of a equals W of minus 1 on 8 ln of 8. Right. Now, if you are to make a the subject, then we have ln of a equals minus W of 1 on 8. Alright, that's, we just multiplied both sides by negative 1 to remove this negative from there. Alright, so we are making a the subject, and this is natural log, so definitely a will be equal to e raised to the power negative W of 1 on 8 ln of 8. Alright, now remember that we are not finding a, but we are actually finding x. Right, from the answer we are finding x, but we know that x is equal to, from the change of subjects we made, x is equal to ln of a over ln of 8. Alright, and we found a to be the whole of this, so we are just going to replace it. We get x equals ln of e power negative W minus 1 on 8 ln of 8. Alright, all over ln of 8. So if you simplify this, you get x to be negative W of minus 1 on 8 ln of 8 all over ln of 8. Alright, now from this point you can use the Wolfram alpha calculator to calculate for the approximate values. Alright, so if you use a calculator to calculate for your absolute values or the approximate values, you will get x to be 1 and a decimal of 0.18281269. Alright, this is a value of x that you will get. Right, so you can use the Wolfram alpha calculator to calculate for the absolute value or the approximate value for this whole expression over here, and then you get your final answer. Right, so this is how you can solve this question using the Lambert function. And as I said at the beginning of the video, if you are not really familiar with the Lambert function, you can check out the video on my YouTube channel to get the concept of the Lambert function. Alright, so thank you for watching. Please do all to subscribe to my channel for more videos. Thank you for watching once again. Alright, so I'll see you in my next video. Bye.